Today we're looking at the Raspberry Pi as a sound rendering module. I got the little board here, USB, network, HDMI to the screen, card, supply, and the USB has got now the keyboard on top, and on the bottom there's a long cable which runs there. This cable here runs to this little box. And a little box contains a USB-DA converter which goes into the amplifier there. And of course, well, here's on, but it has no audio connection at the moment. You can see that. No audio plugs, only a USB cable. And we here have the screen of the Raspberry Pi with my BWise here, and for people who know Linux, Q-Jack control to control Jack, and a little keyboard here. I can operate it with the mouse. And this diagram is it's not really complicated. We have an output block which essentially multiplies, see if I can show that. There are mathematical equations. It says this 1/6 here from output block gate B multiplies with output block gate A, and that's an amplifier, you could say. And then we have these blocks here. They add up in this. You open one of these up, you get, it's all running on the Raspberry Pi. I'm no misunderstanding, there's no other computer involved in running this application. So the X windows, some will recognize these menus here, or the big Raspberry here. The blocks are intended to create sine waves. At the moment, that's the simple thing it does. So the sine wave here is of frequency 430 Hertz, and that's 2 times pi times 430 times 1 plus 0 with a certain amplitude. In this case, an amplitude also of 1. This graph is a mathematical graph in BWise. That's my network program. So I can press run. You can see that there are little transfers going on in that direction always, until it's here at the output, and then at the output we have a mathematical formula, and that mathematical formula gets put into a gets transferred into a Fortran program, and the Fortran program is then also executed by this processor on the Raspberry Pi. And the output of the Fortran program is a wave, in this case, of sine waves, 3 sine waves, and a slightly detuned sine wave added up. So harmonic 1, harmonic 3, harmonic 5, harmonic 1 slightly shifted, harmonic 3 slightly shifted, and harmonic 5 slightly shifted. And that's how the output sounds. That's what we hear if we play on the virtual keyboard. You can also do it on this keyboard. Now the fun part is, if the USB doesn't crap out, to connect a USB MIDI device and have it automatically link it with the program that has been made with the Fortran in it. So let's see if that works. Here we have the USB MIDI. I've set up QJack such that it automatically connects, which we can see here, all running on the Pi. It connects the Kurzweil PC3 with Jack Mini Synth, and so if we now play notes, just a couple, 1 or 2, it's, the X Windows is running, so it's not that powerful at the moment. 2 notes plays.